I am on page 96 of the exercise book, and I've copied this problem over here. And this is number 20. Which of these systems of linear equations has infinite solutions? And infinite means unlimited. Unlimited solutions. So I'm going to go ahead and tell us that the answer is B, and then I'm going to show you why. I don't want to spend a whole hour explaining how to find this. I'm just going to show you why B is the answer. So let's bring the system over here. We have 4x minus 4y is 12. And then I have 7x minus 7y is 21. So I need to use the elimination method to get these on equal terms. So I think to do that, I'm going to multiply this one by -7, which means this side will get multiplied by -7. And I liked working across the page last time on this, so let me try that again. So this is going to become -28x plus 28y equals -84. Now be careful with those negative signs. I'm going to just check mine again because y'all know how I am. Okay. On the bottom, I'm going to multiply everything by 4. So this will lead to 28x minus 28y equals 84. Okay, so then I start canceling. I cancel my x's, I cancel my y's, and I cancel my constant. Everything cancels. So that tells me that there are infinite solutions. I could choose values for x and y all day, and this is going to work because x is changing at the same rate and y is changing at the same rate, and the constants are going to change at the same rate. So because everything cancels, this has infinite solutions. And so the answer is A. If you worked the other 4, and I'm not going to take the time to do that, but if you worked those, you would not get this situation. You would get values for x and y. But because everything cancels, there are infinite solutions. Okay, let me go ahead and bring in problem 21. I need to crop it and get the one we want to work. And this one says which ordered pair is a solution to the system. Remember, the solution to a system is a point. So we're looking for the point. So we've got 3x plus 5y is -64. And then 4x plus 3y is -56. And we are supposed to use the elimination method to solve these. So let's zoom in here, focus right here just a minute. So I'm going to use a -4, and I need to do that on both sides. So we will get -4 times +3 is -12x. Negative 4 times positive 5 is negative 20y. And then I'm not even going to try at 3:30 in the morning. 12 times 20. No, what am I doing? 4 times 64 is 256, and that is positive. Then on this one, I'm going to use a positive 3. So I'll have a 12x. I'm trying to get those to cancel. Plus a 9y equals, and you got to do it on this side too, it's going to be a negative term. 56 times 3 is 168. So these are going to cancel. And then the y's, you would have negative 11. And over here you have a positive 88. So let's divide both sides by negative 11. And that will give us our y value of negative 8. So that's the y coordinate. And then I need to figure out the x coordinate. So using one of the equations, and I will change colors to do it, I have 3x plus 5y is negative 64. And we're saying that y is negative 8. So go ahead and plug that in. And you'll be left with 3x minus 40 is negative 64. So add 40 and 40 and cancel. So 3x is negative 24. Divide by 3 and cancel. So x is negative 8. And that gives me the other piece of that point, the negative 8. So let's find the one that matches. Looks like A is going to be the one that we want. So number 21 is A. Okay, number 22. Let me go to a new page and paste. This is another story problem. I love the story problems. To me, they make so much more sense than just numbers but they're not easy. I'm not saying they're easy by any means. All right, number 22. Tickets to a school play cost $5 per student and $8 for each adult. How many of each kind of ticket were sold if 500 tickets were sold? And the play brought in a total of $3,700 in ticket sales. So we know that the adult, or let's say children, student first, doesn't matter, plus the adult equals the total number of tickets sold. The students were $5 each. The adults were $8 each. And we know that they sold $500 in tickets. So if you're talking about money, that's your equation. If you're talking about just plain old tickets, you would just take the students and the adults. Excuse me, I have this backwards. The money goes with the one that has the prices. So let's put our 3,700 up here, because this is all talking about money total, and then this is just talking about ticket total. Okay, there's our system. And I'm going to first of all solve this one. for student, I guess. It doesn't matter. But I'll move the A and cancel. So S equals negative A plus 500. Okay, and then I bring in the other one, which is 5S plus 8A. Let's calculate the money for each. And we know that S is worth negative A plus 500. And then we have 8A. Oh, I did it wrong, guys. I'm doing it with substitution. I'll do it the other way. Just 1 second. I'm so used to this that I didn't even think. I'm supposed to be using elimination. Sorry. Okay, so let's move the 2,500. So that leaves me with negative 5A plus 8A. And this leaves me with 1,200. So this would be a total of 3A equals 1,200. Divide both sides by 3. So the number of adult tickets sold was 400. All right, and then you can substitute that back into the other equation. I'm going to use this one. So we have students plus the adults that we just talked about are 500. So the students would have to be 100. So S is 100, A is 400. So I'm liking answer A for this one. Now I'll do it the way I was supposed to. This is called the substitution way. And this is the way that I was trained to do these. I think my professor was just a little bit partial to this method and wanted us to do it all the time. But let's do it with elimination and see what we come up with. So I'm going to bring this same set of equations down. We don't need new equations. We're just going to solve it a different way. And I'll change the word there. So instead of substitution, we're going to use elimination to solve this one. And this one is ideal for elimination. And I'll show you why, if you don't already know why. Remember, graphing is another way to solve it, but I do not want to do that. This one is ideal for elimination because of this. When you have a variable by itself, and it can be this one or this one, those are the kind you want for elimination, because then you just have to multiply once. You don't have to do both equations. So I'm going to do this single one on the bottom because I need a negative 5 there. I want a negative 5 to cancel. So in order to do that, you just have to multiply everything by negative 5. That's the catch. So you get negative 5S minus 5A equals negative 2,500. And then once you've got that, you can get rid of this section. Okay? So then you're going to cancel your S terms. The student terms just cancel away. And you're left with 8A minus 5A, that's 3A, equals 1,200. And look at that. Adult is 400. Just like we got in the first one there. And then you would have to substitute back into an equation to get the students. So 5s plus 8a is 3,700. And so that's 5s plus 8 times 400. We did this once, didn't we? I don't know. No, I used the other equation. So this will work. 5s plus 3,200. I've done this somewhere. 3,200 equals 500. Divide by 5. So this number of student tickets were 100. So on a test, you choose the method that you want to use. You can use elimination, like I did here on the bottom, or you can use substitution, like I did up here on the top. But either way, you will get your answers. And do I have another one on this page? Oh dear. I'm going to stop this video because I have to go back and copy the number I need next.